Hi, today we'll discuss the LeetCode problems number 6, Zigzag Conversion. Given a string, and here is the input string, and it will be written in the zigzag pattern on a given number of rows. So it will be like this. The input string starts with PayPal, so it will be written like PayPal. And you continue this pattern. So the pattern is you will go down, then you go diagonally up, then go down again, and go up, down, up. So this is called zigzag pattern in this problem. And read line by line. So after this string is written in the zigzag pattern, then in our output, we'll read line by line. So here is the first line, and second line, and third line. The first line is PAHN, and here is the example. So the first line is PAHN. The second line is APLSIIG, APLSIIG. And third line is YIR, YIR. So basically, this question asks you to transform this input string into this output. And the way to transform the input string to the output is to write input string in the zigzag pattern and read line by line and to form this output string. Let's analyze the problem with the same example. We can think of the 3 rows in zigzag pattern 3 strings. For example, the row number 1 is a string 1, and the row number 2 is a string 2. Row number 3 is a string 3. So let's write the string 1 here, string 2, string 3. We start with the first letter in the input string. So here, the first letter is P. We put the first letter in the row number 1. It's the same as put the first letter P in the string 1. So we put P here. And the second character is A. We put it in the string 2. We put Y into the string 3. Because we only have 3 rows, so we only have 3 strings. Now when we reach the bottom, then we will go up again. Now we reach the letter P. The bottom row is 3, so when we go up, we put letter P into the row number 2. So we put P into the string number 2. Then A is in row number 1. We put A into the string number 1. When we reach the top row, then we come back down again. So L is in the string number 2, and I in string number 3. Then we go up again. We put S into string number 2, and H in the string number 1. I, string number 2. R, string number 3. I, string number 2. N, string number 1. And G, string number 2. G is the last character in the input string, so our process stops here. Once we put all the characters into these 3 strings, we concatenate these strings to create the output string. So here is output. Our output will be string 1 plus string 2 plus string 3. So string 1 here, and the string 2 We concatenate string 2 after the string 1, then string 3. As you can see, the output string we just created is exactly the same as the output string in the example. Next, we will create a pseudocode based on our analysis. First, we need a list of the strings. And we call it string list. And the size is the number of rows. And we need to declare two integer variables. The first is the row index. We start with 0. We are going to use this row index for the index of the string list. And the second integer variable is the step. We initialize the step with the -1. So this is the moving step for the string list. And it has two values. For -1, it will move upward. And if the value is 1, it will move downward. First, we are going to have a for loop to visit each character in the input string. The first step in the for loop is to add the character in one of the strings. So we use this row index to identify in which string we are going to add this character. Then the next, we need to check if our movement reaches to the top or it reaches to the bottom. If it's at the top or bottom, we're going to flip the moving direction. The way we flip the moving direction is by changing the sign of the step. And the next step is we'll move the row index. Once we visit all the characters in the input string, we will concatenate the strings in the string list. Okay, let's run an example with our pseudocode. This time we'll use example number 2. So in the example number 2, we have input string here, and the number of rows is equal to 4. So with our pseudocode, we will create a list of strings with the size of number of rows. First, we enter the for loop, and our index is pointing to the first letter, P. And here we keep track of the step. The step is equal to step times -1. We also keep track of our row index. Is equal to row index plus step. The initial value for the step is -1, and the row index starts with 0. And the first step, we add the current character to the string 0. Now let's change this. So we add the first character P in the string list 0. Next, we will check if it's at the top or the bottom. The string list 0 is at the top, so we need to flip the moving direction. Currently, the value for the step is -1. Then we times -1, it gives you 1. And next, we will move the row index. So the index row is 0 plus 1 equals to 1. Then we move to the next character, A. We add A to the string list 1. Row index equal to 1. A. And we check if at the top or bottom it's not. Then we move the row index. Here the step remains at 1. And the row index 1 plus 1 equal to 2. We move to Y. We add Y to string list 2. And we do not update step because it's not at the top or bottom, but we update the row index. It's equal to 2 plus 1 equal to 3. Next, we move to character P. We add the P to string list 3. Now we check if it reaches to the top or bottom. The string list 3 is at the bottom, so we need to flip the moving direction. Here's 1. 1 times -1 gives you -1. Then we calculate the row index. Three plus -1, it gives you 2. Then we move to the letter A. We will add A to string list 2. Then we check if it's at the top or bottom. It's not. Then we move the row index. So the steps remains as -1. Then the row index is equal to 2 plus -1 is equal to 1. Then we move to the next character, L. We add L to the string list 1. Then we check if it's at the top or bottom. It's not, so we skip this step. The step remains as -1. Then we calculate the row index is equal to 1 plus -1 is equal to 0. We move to I. We add I to the string list 0. It reaches to the top, so we will flip the direction. -1 times -1 equal to 1. The row index equal to 0 plus 1 equals to 1. We move to the next character, S. We add S to the string list 1. The step remains as 1. And we calculate the row index is equal to 1 plus 1 gives you 2. We move to the letter H. We add letter H to the string list 2. Remains at 1. and the row index will be 2 plus 1 equal to 3. Move to I. We add I to the string list 3. It reaches to the bottom, so we need to flip the step. Step is equal to 1 times -1 equal to -1. And the row index is equal to 3 plus -1 equals to 2. It moves to R. Then we add R to the string list 2. The step remains as -1. The row index equals 2 plus -1. It gives you 1. We move to I. We add I to the string list 1. Step remains as -1. Row index is 1 plus -1 equals to 0. We move to the character n. We add n to the string list 0. It's at the top row, so we need to flip the step. It's equal to -1 times -1. It equals to 1. And the row index is equal to 0 plus 1. It equals to 1. Then we move to the last character in the input string, G. We add G into the string list 1. Okay, since we reached the last character in the input string, we exit the for loop. The last step is to concatenate these strings in the string list. We have string list 0, string list 1, two, and 3. Okay, we finished our demo here. As you can see, our output string is the same as the output string in the example. Next, we'll go to the LeetCode website to implement the solution based on our pseudocode. Here's the pseudocode I have prepared in the LeetCode website. In the beginning of the implementation, I have an if condition here. Is to check if the number of rows is equal to 1 or the length of the string is smaller or equal to the number of rows. We just simply return the input string without doing any of the work below. These conditions applies to the example number 3. As you can see, the input is just A itself, and the length of the string is smaller or equal to the number of the row. We simply return the input string. After the if condition, the first step is to create a list of strings based on the number of rows. We're going to have a list. We're going to use the string builder because we keep adding the characters into the strings. And we call the string list. Once we declare the array list, we're going to initialize the string builder in the array list. Depends on the input of num rows, we're gonna create the number of string builders. And here, we declare the two integer variables. The first is the row index. We initialize the row index with 0. We're gonna use the row index to iterate the string in the list. And the next integer variable is the step. The initial value is -1. For the step, there are only two values. It's either 1 or -1. If it's 1, it will move downward, and if it's -1, it will move upward. Here, we'll have a for loop. The first step is to add the current character to the string specified by the row index. Next, we're going to check if we are reaching to the top or bottom of the array list. When it's equal to 0, it reaches to the top. Or when it reaches to the number of rows -1, which is the last index of the string in the list. If it's true, we're going to flip the moving direction. The next step, we're going to move the row index. So these are the steps in the for loop. Once it exits from the for loop, we're going to concatenate all the strings in the array list to create an output string. So here, we'll iterate each string in the array list, and we append the string into the output string. The last step, we are going to return the output as a string. So here is the implementation for our solution. Let's run the code. It passed the test. Now let's submit the solution. The submission was successful. The runtime is 5 milliseconds and is faster than 79% of all the online submissions. So the runtime of our submission is 5 milliseconds and is faster than 79% of all the online submissions. Now let's discuss another approach for this problem. In this problem, all the characters are arranged in the zigzag pattern. So we can create a formula for this zigzag pattern to transform the input string to the output string. Let's analyze this approach with an example. For example, here is our input string. The characters in the string are from A to P. Let's say we are going to put these characters into a zigzag pattern of 4 rows. The num of rows is equal to 4. Here is a matrix of the zigzag pattern. In this matrix, we can see the characters are arranged in the repeating pattern. From here to here is the first cycle, and from here to here is the second cycle. To here is the third cycle. This is the row number 0, 1, 2, and 3. And here is the cycle 0. Here's the cycle 1. And the cycle 3. Actually, here is the cycle with index 2. The first character in the first cycle is the character A. Is corresponding to the character A at position 0 in the input string. So our starting point of the first cycle is 0. And the first character in the second cycle is the letter G, and is corresponding to the G at position 6 in the input string. So second cycle starts at 6. And the first character in the cycle 3 is the letter M. So this cycle starts at 12. Now let's calculate the cycle length of one full cycle. In the first cycle, we can see, except the top row and the bottom row, all the rows in the middle have 2 characters. And in the top row and the bottom row, there are only 1 character. So the cycle length is equal to 2 times num of rows minus 2. In our example, the num rows is 4, so the cycle length of the full cycle is 2 times 4 minus 2 is equal to 6. And we can see from here, here is a full cycle, and it's from character A to character F. There are 6 characters in the full cycle. Now, let's discuss the formula to calculate the position in the input string for each character in the matrix. For example, the letter A in the matrix. We need to use the formula to calculate what is the position in the input string for the character A. And first, we will look at the characters in the first column of each cycle. So the characters in the shade are the characters in the first column of each cycle. Let's first look at the character A. A is in the cycle starts with 0. And it's at the row with index 0. So the first number is the cycle starts. And the second number is the row index. So for character A, the coordination is cycle starts at 0 and the row index is 0. And now we're going to use these two numbers to calculate the position of A in the input string. So here we're going to have position. As we observe, A is at position 0 in the input string. So here the position is 0. Now the formula is going to be 0 plus 0 equal to 0. Let's write down the formula of this scenario. So for characters in the first column in each cycle, the position is equal to cycle starts plus row index. Let's verify this formula with the rest of the characters in the shade. Now let's move to the character B. The cycle start for B is 0, and the row index is 1. The position will be 0 plus 1 equal to 1. And we can observe B is at the position 1 in the input string. C is 0 plus 2 equal to 2, and C is here. D is 0 plus 3 equals to 3, and D is here. We have validated all the characters in the first column in the first cycle. Now let's validate the characters in the first column of the second cycle, G. The cycle start for G is 6, and the row index is 0. So 6 plus 0 is equal to 6. And we can see G is at position 6 in the input string. H, 6 plus 1 equals to 7. I, 6 plus 2 equals to 8. And J, 6 plus 3 equals to 9. As we can see from the input string, the characters from G to J are at position from 6 to 9. Now let's examine the characters in the first column of the third cycle. M, the cycle starts at 12. And M is in the first row of the matrix. So the index of the row is 0. 12 plus 0 is equal to 12. N is 12 plus 1. Gives you 13. O, 12 plus 2 equals to 14. P, 12 plus 3 equals to 15. The characters M, N, O, P are at positions from 12 to 15 in the input string. We have examined all the characters in the first column of each cycle. Now let's examine the rest of the characters in each cycle. For the rows which are not at the top or the bottom, it is possible that there is a second character in the cycle. For example, the character E at the row 2 and the cycle starts with 0. And also, the character K in the cycle starts at 6. And in the cycle starts at 12, there's no character because our input string ends with P. So here, in the rows are not at the top or bottom, it is possible to have a second character in the row and in its cycle. For example, E at the row number 2 and the cycle starts with 0. And let's look at the character F. Character F is at the row which index is 1 and in the cycle starts with 0. F is one character away from the next cycle, which starts at 6. And the position of F in the input string is 5. So the formula is position equal to cycle start plus cycle length minus row index. For example, the character F. The cycle start for character F is 0, and cycle length is 6. And the row index for letter F is 1. So the formula is 0 plus 6 minus 1. And it equals to 5. So for character F, it's at the position 5 in the input string, which is here. And the character E, cycle starts at 0, and the cycle length is 6. The row index is 2. 0 plus 6 minus 2 equals to 4. And the E is at position 4 in the input string. Now let's look at character L. In the cycle starts with 6. The cycle start for L is 6. The cycle length is 6. And the row index is 1. 6 plus 6 minus 1 equals to 11. Now let's look at K. The cycle starts with 6. The cycle length is 6. And the row index is 2. 6 plus 6 minus 2 gives you 10. And the K is here at position 10. Now we have examined all the characters in the matrix. So we need these two formulas to calculate the position for each character in the matrix of zigzag pattern. Let's create the pseudocode based on our analysis. I have prepared all the detail here we already discussed before. Our algorithm is about to calculate the position of the character in the input string and put that character in the output. Here is a matrix in where the characters are ranged in the zigzag pattern. And when we add these characters into the output, we'll read line by line. So first we read row 0, then we read row 1, row 2, and row 3. So we will have a for loop to iterate the rows. And here we declare an integer variable called row index. Starts from 0. And we end the loop when the row index reaches to the number of rows. Let's say we are reading the row 0. First, we'll read the characters in the first cycle. Then we will read the characters in the next cycle. So we're going to have another loop inside of the outer loop to iterate cycles. And we will declare an integer called cycle start. And here we're going to have condition to end our loop. In each row and in each cycle, it always starts with the character in the shade. For example, in the row 0 and the cycle 0, the starting character A is in the shade. And also in the row 0, cycle start 6, the first character is G and is in the shade. And the formula for these characters is here. So the starting condition in the inner loop will be cycle start plus the index of the row smaller than string length. And the way we go to the next cycle is to add the cycle length to the cycle start. So the first cycle is 0. Then when we go to the next cycle, we use 0 plus the cycle length, and it gives 6. So here is cycle start plus equal to cycle length. The first step for each cycle in the loop is to calculate the position of the first character. So the first character is the character in the shade. So here we calculate position of first character. So we call it P1. And the formula for the position of the first character is the cycle start plus row index. So here we have position 1 equal to cycle start plus the row index. Once we have the position, then we'll add the character at this position in the input string to the output. So output we have an index here equal to the input string dot char at P1. So here we declare an integer variable called index, and it starts with 0. And after we add the character, then we move the index to the next empty spot. For example, at the row 0 and the cycle 0, the position for the first character is 0 plus 0 equal to 0. So at the position 0 in the input string is A. We put A in the output. Then we move to the next empty spot. Then our inner loop will iterate to the next cycle. It comes to this position. So the character here is at row 0, cycle start 6. Then the position for this character is 6. In our input string, 6 is G. Then we put G next to A. And the same thing for this character. The cycle start is 12. The row ID is 0 and the position is 12. So we'll put M here because at the position 12 is character M. So the code here is the first step. Then we will check if in this cycle at this row there exists a second character. As we observed from this matrix, the top row and the bottom row has only one character, so only the rows in between can possibly have the second character. So here, for our check, we have a couple of conditions. The conditions are rows are not at the top or bottom. Let's look at the row 2. In the first cycle, the cycle 0, it has a second character E. And in the cycle 1, it has a second character K. And in the cycle 2, it doesn't have a character. If we calculate the position for the second character, the position will be outside of the string length of our input string. So we have to compare the position we get with the length of the input string. The formula to calculate the position of the second character is this one. We call it P2. P2 equal to cycle start plus cycle length minus the row index. Then we check if P2 is smaller than the string length of the input string. If it's true, then we will add the second character into the output. So from here to here is our second step. Let's continue with our demo to test our pseudocode. After we put M in the output, we'll go to the next cycle. The next cycle has a cycle start 18 and is longer than the length of the input string, which is 16. So our inner loop will stop, then go back to the outer loop. Outer loop was at row 0. Now it comes to the row 1. Once it enters the row 1, then it will start with the cycle 0. At the cycle 0, it will first calculate the position for the first character. At the cycle start 0 and the row 1, the position of the character in input string will be 0 plus 1 equal to 1. And it's character B. So we put B here. And then we check if there is a second character in the cycle 0 and the row 1. So we check the three conditions. The row 1 is not at the top and is not at the bottom. And when we calculate the position for the second character, it gives row start 01 plus the cycle length and the minus the row index, which is 1, it gives you 5. And the 5 is smaller than the string length of the input string. So we can safely get this character from our input string. We get F. So we will continue this process to put H in the output and L in the output. And we come to the cycle starts with 12. The first character in the row 1 is n, so we can add n in the output. Then we will check if the second character exists. If it exists, then it will be here. But if we calculate the position at this spot, the position will be greater than the string length of our input string. So our inner loop will stop here. Then it will go to the row 2. To calculate the positions of the characters in the row 2 is same as row 0 and the row 1. So I will not spend time to go through each character. We will end our demo here. Next, we will go to LeetCode website to implement the solution based on our pseudocode. Here is the pseudocode I have prepared in the LeetCode website. First, we have a condition to return the input string if the number of rows is equal to 1 or the string length is smaller or equal to the number of rows. I already explained this condition in our solution 1. And here we declare an integer variable called string length. And here we declare a character array output. In this character array, we are going to add character by character from the input string. And here we have an integer variable called cycle length. And the formula is 2 times the number of rows minus 2. And here we have an integer variable called index. This index will be used in the character array output. First, we'll have an outer loop to iterate each row. Inside of the for loop, we'll have an inner loop. It will iterate from cycle to cycle. And when it goes to the next cycle, the cycle start will be increased by cycle length. The first step in the inner loop is to calculate the position of the first character, P1. And here is the formula for the P1. And once we have the P1, we will add character at the position P1 in the input string to the output. So here, the formula for P1 is cycle start plus row index. And the next will increase the index. So we can increase the index here. So this is the first step. The next step, we're going to check if the second character exists. There are 3 conditions here. First condition, the row is not at the top. And the second condition, the row is not at the bottom. And the third condition, the position for the second character must be smaller than the string length. So if all the conditions are true, then we add the character to the output. So we have an if statement here. The first condition is we will check if the row index is at the top. And the second condition is the row index will not at the bottom. And the third condition, we will calculate the position and compare the position with the string length. If all 3 conditions are true, then we are going to add the character from the input string into the output. Same as the step number 1, after we add the character, we will increase the index. So these are the steps to calculate the position of the characters in the input string. And then we will use the position to add the character into the output. To make it more clear, I will delete all these comments. After the calculation, once we have the output, then we will return the output as a string. This is all the implementation we need to do. Let's test our code. It passes the test. Let's submit the code. The submission was successful. The runtime is 4 milliseconds and is faster than 86% of all the online submissions. So our solution 2 has runtime 4 milliseconds and is faster than 86% of all the online submissions. So this is the status for our solution number 2. And remember, our solution 1 had runtime 5 milliseconds. And it was faster than 79% of all the online submissions. So our second solution is better in performance. Okay, that's all we need to discuss today. Thank you for watching.